But today, we're sort of going to look at the range of stone tools that are present, well, through the Paleolithic. And just on the front sort of screen here, I've tried to capture some of the different types of technology that we have. So Shreya's already thrown some names in helpfully. The oldest stone tool technology we have is the Lomekwian, dated to about 3.3 million years ago, coming from East Africa, and that's what this large flake at the bottom left looks like. The next sort of technological name is the Oldowan, named for artifacts found at Oldupai Gorge in Tanzania, and that's sort of, we've got an Oldowan core here, a chopper, and in the top left-hand corner. Then my personal favorite are the Acheulean hand axes, and hand axes are produced from about 1.7 million years ago, right the way through to about 200,000 and less. And hand axes, I think, as we'll see, are where my specialty really lies. And then in the top right-hand side, we've got what's called mode 3, or sometimes in European nomenclature called Levallois, and the Southern African nomenclature. And then the bottom right are blades, which is mode 4. So in the European literature, that's referred to as the Aurignacian. And there are various subdivisions of all of these technologies, depending on where you are in space and time. So sort of first of all, I'd probably just like to apologize slightly that most of my teaching and my lithics experience is European and African based. I'd love to become more familiar with the amazing stone tool record that we have in India. It's always looked to be utterly amazing to me and incredibly rich. So there, I have tried to incorporate some examples of Indian artifacts within the talk today, but not as much as I would ideally have liked to have done. But hopefully one day when all this is over, I can come and have a look at some of the amazing Paleolithic record in India. Okay, so first of all though, just to kind of zoom back out again, let's sort of start thinking about what does the word lithic mean, or what do we mean when we use that term, or what do I term? Well, lithos means stone, and stone is basically any kind of rock. So here's an example of a stone, and you're going to be seeing a lot of this particular one. This is a cobble given to me by Golan Sharon from Jordan, I think. So stone is any kind of rock. However, when we talk about lithics in relation to stone tools, we are talking about objects that are made by people either in the present and all the way back through then into our evolutionary history in the past. So the term lithic in an archaeological context of it. And I think it's important to sort of establish at the very beginning here that wherever people have gone in the world, over the, sort of dispersing out of Africa from perhaps as much as 2 million years ago, wherever we have gone, we have used stone tools, it seems. And we'll talk about the various timings of these different technologies as we move forward, but stone tools, as well as presumably a very rich organic industry, which just doesn't preserve as well in the record. We have a long technological history. So when people use the term Stone Age, they typically use that with the use of stone, and there are different terminologies used in different parts of the world. So in the European terminology, the Paleolithic refers to the Old Stone Age, and that typically dates from our current knowledge base from about 3.3 million years ago to about 10,000 years ago. And that Paleolithic in the African stone tool chronology relates to the Old Stone Age and the Middle Stone Age, and then the later Stone Age. In the European term, then from 10 to 7 or 6,000 years ago, we have the Mesolithic, which is sort of translates as the Middle Stone Age, and then the Neolithic, which is the New Stone Age, and that's dated from about 7 to 6,000 to 4,500 years ago. And different places in the world will have these sorts of these terms as well, but crucially the dates will change depending where we are in the world. This is the European chronology. And then the rest of that later prehistoric period, it's, I think, also important to understand that certainly within the European record, and I think the same remains true elsewhere, that even as we move into the Metal Ages, so the Bronze Age and the Iron Age, stone tools still remain an important part of the toolkits and the society, and how those societies kind of interact with material culture. And that, I think, for me is fundamental, because stone tools are the bedrock of our one of the bedrocks of our technological accomplishments, really. So if we have a look at this diagram, which is just a timeline of human evolution and showing the various genuses and species that we know about from the fossil record. Stone tools have been around for about 3.3 million years. So the oldest stone tools we have date to 3.3 million. And then every other technology that we have ever invented is less than the thickness of that red line that just moved across your screen and sitting now on the left-hand side. So every other technology we have in the world, other than perhaps the use of or the manipulation of branches and things like that. But in terms of the technologies that ultimately lead to our sort of mobile phone devices, laptops, and however else you're accessing today, all of that technological history from agriculture forward is less than the thickness of that line. Now, stone tool use has been with us for about 3.3 million years ago, and we know that primates, chimpanzees, gorillas, orangutans, so on, are also tool users, and that they manipulate branches to create walking sticks to cross submerged landscapes, to check the depth before they go. That's what gorillas have been observed to do. Chimpanzees have been observed to make wooden spears to hunt bush babies. You know, these are also tool users, but they fall in the organic realm. Now, unfortunately, within the Paleolithic records and the deep time that we are sort of focused on, often those sorts of things don't preserve very well, other than exceptional circumstances. Now, I'll try and highlight where that's possible, but certainly wouldn't surprise me if in the future it became realized that there was a much richer organic toolkit that either preceded the stone tool use or indeed supported and underpinned it as we move through. Just something to bear in mind. The stone tools are our focus for the Stone Age, because those are the things that have preserved in the record because of their durable nature. But then I'm really convinced that there must be a very rich organic toolkit that sits alongside them. So why are stone tools, or the helpfully summarizers? Stone tools and other artifacts offer evidence about how early humans made things, how they lived, how they interacted with their surroundings, so their subsistence strategies, and how those changed or evolved over time. So we know that we have a stone tool record that spans almost 3.3 million years. And from that, we have many thousands of archaeological sites that have been excavated, studied, and dated across the world. These sites consist typically of accumulated debris from the making and using of stone tools. And because stone tools are less susceptible to destruction and degradation than other artifacts, than bones, for example, and wood, they offer the best evidence available to us of where and how humans lived, what their geographic dispersal was, and their ability to survive and adapt to a variety of habitats. And since often multiple human species existed at the same time as each other, and certainly our realization and understanding of that has increased exponentially, it's often difficult to determine which species made the tools at any given site. But as humans, we love to categorize and box things up into nice, simple, bite-sized chunks or categories that we can say, this tool type belongs to that human species, this one belongs to this one, and so on. And certainly, as we go through today, you may well leave the lecture with that impression in mind, but I'm just going to highlight now that's really not the case. Often we don't know who made what certain types of tools, because we have these multiple species in landscapes at the same time. So just bear in mind that there's a complexity there, which just by sort of the route of explanation today in terms of trying to learn a bit about stone tools, it sometimes simplifies that picture a bit. But really importantly, stone tools provide evidence about technology, can tell us about dexterity, can tell us about mental skill, cognitive ability, can tell us about innovation that were within the grasp of those tool makers through time. So this is just a warning slide. Sorry, I'm just going to move the screen over to the left here. As I said before, we love to be able, to think that we can associate certain stone tool typologies or types to specific human species. And certainly much of the older literature has really been driven towards that. And it's about, demonstrating a linear progression in tool technology that goes from simple to complex through time. And as things become more complex, we should be able to map those onto specific species. And ultimately, it's, the culmination as Homo sapiens at the end of that spectrum, who are the most complex of all human species. I'd just like to emphasize that's not true. I don't think that's true, or that it's ever been true. And, we just need to be cautious about trying to do that. What is true, though, is at a broad sort of global scale, there is a general movement through time from a more simple technology to a more complex technology at a broad scale. But that is punctuated at local scales about continuous movements of people who reinvent technologies and innovate technologies through time. Those innovations get lost. Then another group might come along and re-innovate a similar technology later on, and that gets lost. So the picture of technological development through time is broadly simple to complex, but we have to understand that the actual practice of that on the ground is not a simple linear scale. And I'll try and allude to some of this as we go through, but just to sort of a warning to keep that in mind. Okay. And certainly if you look at the record then in a way that we've tried to present here with Julia Galway-Witham and Chris Stringer in our 2019 paper, where you've got fossil hominins on the bottom, brain size in the middle, and then different types of technology across the top. You can see that once these stone tool technologies come through, so the Lomekwian, for example, at around 3.3, there are multiple species that could belong to. We don't know who made the Lomekwian. When you get to mode 1 or flake and core or the Oldowan, again, there are multiple species who could be making this technology. I doubt it's just a single species that's doing that. The same goes for Acheulean bifaces or mode 2 technologies. We know that multiple species made these artifacts. And, the reason for making a hand axe at 1.7 million years ago is not going to be the same as the reason for making that hand axe at 200,000 years ago. And equally, that's going to change depending where you are geographically. So there are within, the production of these artifacts that look broadly the same for long periods of time, there are different reasons and meanings for making them. And that's what makes the study of stone tools so exciting, I think. Similarly, for what's called mode 3 or the Laval, the prepared core technologies, there are multiple species who could have made those in Africa, Southeast Asia and Europe. And mode 4, which is most often associated with our species in Africa and outside, equally there could be other human species who have independently innovated mode 4 type technologies. Okay, so stone tools. What do we mean by stone tools? What are they? So This prop that I'm going to sort of be using quite a lot today is just a natural piece of stone, if that's what you were thinking the first time I showed it. There's nothing worked about this piece. It's just a cobble from a river, but it's a really useful prop. The other objects that I'm going to bring into the screen periodically are archaeological artifacts or sort of modern experimental reproductions. But stone tools are you have kind of two basic components. You have what are flakes, if you look at this panel A, and what is a core. Now, a core is going to be your source material. So that's your lump of raw material that you want to exploit. And generally speaking, the thing that is useful to people are the flakes or the derived artifacts that come off that. Sometimes, though, people will turn cores into tools by doing a bit of shaping across them, and we'll talk about those as we go through. In other ways, certainly once we start getting onto hand axes, there's deliberate imposition of form and shape on those, and that has a different implication. But effectively, to make stone tools, you have to understand that this is a reductive technique. So to make an artifact, you nap it, and that's with a K, by striking your raw material with your hammerstone. That will detach a flake. The flake either is something you want to use, or it creates the shape or a space for the next flake to be removed, and then that kind of allows you to access the potential of the raw material for whatever you wanted to do. Generally, stone tools are made initially for processing purposes, and that can be for processing carcasses, so butchery of carcasses to access the meat and the marrow within the bones, and almost certainly for also processing and shaping bits of wood and bone. So the next question is, how can you tell whether something is a stone tool or just a natural piece of rock? And just slightly before we get onto that, I think it's also useful to understand that engaging with stone tool technologies is tricky in many ways, because there is a great temptation from archaeologists and all of us to see the result of something that has been napped and left behind by people in the past as the intended finished product. So, if I hold this hand axe up, for example, it's a great temptation for me to think, wow, these people have really put a lot of effort into shaping and forming this tip in a very symmetrical, defined way. That must be exactly what they intended to do. That they then discarded this hand axe as the final finished form. And I come along 200,000 years later, and I start looking at this object and start to make inferences about behavior, about cognitive ability, because I think I'm looking at a final finished form. The complexity of the archaeological record, of course, is that anything could be lost at any stage of manufacture at any time, and that's the same for any period of archaeology. So in these two examples on the screen, if I start with the bottom one first, here you've got a flake that's called a cortical flake. And the cortex is effectively, if you think of it as the skin of your raw material. So in this cobble, this flint cobble that I'm holding up, it's this rough surface around the outside. Once you sort of once you remove some of that, you get to kind of the clean surface, flint surface in this example that you can see where I'm pointing out now. So the cortex is like the outer skin, if you want to think of it that way. That shows that that's a very early removal in your reduction sequence. Now, in this example, the intended end product is the flake on the right-hand side. Okay, and that flake on the right-hand side has been napped and deliberately shaped into what's called, a very technical term, but a convex transverse side scraper. Just means it's been shaped through use, but you've got this kind of definite curve. That's the intended end product. However, if I find the flake after it's just been detached initially, my behavioral interpretations around the complexity of behavior will differ vastly between what's on the left versus what's on the right. Now, in the same way that on the top line, the intended end product could be the spear tip or convex convergent side scraper. in terms of the way that it's been shaped, and how we would term that in a very technical lithics way. But if I find it, you know, early on in the shaping process, in terms of the image on the left, the behavioral implications I will draw will be very different. There's nothing really we can do about that, because we will never be able to access the true intentions of what these people were doing, you know, 10,000 years ago, 50,000 years ago, 200,000 years ago, 1,000,000 years ago, 3 million years ago. We just need to be aware that when we are starting to draw our behavioral interpretations, we don't necessarily do them on single artifacts, but groups of artifacts as a whole. And, you know, what we're looking at might not be the actual intended end product. In practice, that's quite hard, because, you know, once you get the lithics bug, it's not unusual to spend many months staring at tens of thousands of these tools, and you sort of start to get a feel really for perhaps what you think the intention is. But we just need to bear in mind that there's sometimes a fallacy there of the finished tool that we're holding in 2020. It might not be the intended object that was created in, I don't know, 250,000 years ago. Okay, so just to sort of just highlight what that cortex is again. Cortex is the outside skin, and effectively, as we move from the left, so Nick Toth has produced various Toth types to describe cortex. From the left to the right, you're effectively moving through the napping sequence. So the more cortex you have on your flake, the earlier in the napping sequence it is. The less cortex you have on your flake, the later in the napping sequence it is. And to get into this later napping sequence, where effectively you have no cortex on your flake, what that means is to sort of, as well as telling you about napping sequences, it can tell you about expertise, because hominins have managed to reduce that core, you know, removing all of the outside cortex whilst maintaining their flaking angles, and I'll talk about those in a moment, and to produce an end product that has no cortex on. So there's a certain degree of skill required to get there. So the amount of cortex on your flake can tell you about where that flake occurs in the napping sequence. So here's a flake, for example, with a bit of cortex around the tip here, or sorry, around the end. So that tells me, although there's no cortex on most of this flake, that little bit means that it's still towards the outside of the core rather than deep from the kind of the middle of the core sequence, if that makes sense. So what are flakes? Well, flakes are effectively the bits that come off the core when you nap it. So if I've got my core here, sorry, I'm just trying to hold it so that you can see all the bits that I'm trying to illustrate to you. So if I have my core and I've got my hammerstone and I strike the top, force travels through the core, the flake detaches. The flake is the piece that comes off the core. The core is your raw material source, okay? Sometimes you will read that there's a term called debitage. A lot of the lithics analysis terminology and knowledge is grounded in French lithic analysis. So sometimes these things are called debitage. We tend to only use that term for broken or whole flakes that are not seen to kind of then be part of creating any sort of flake tool. So they're sometimes termed what are waste flakes, just the natural process of wastage through napping rather than creating sort of intended flakes for use. Just to keep that in mind. Let me move this to the left, sorry, so I can sort of demonstrate. Okay, so when we're napping, the core is this block of raw material on the left, and then two flakes have been detached here on the right. In order to extract your flakes, you have to have an understanding about your napping angles. So you can only extract a flake if you've got a napping angle of 90 degrees or less on your core. And that's because when you strike your core with your hard hammer or your hammerstone, force is being transferred through your blow into the core. And in order to extract a flake, you need that force to travel through the core and exit out to enable you to kind of get that flake to come off. If you strike the core, say here, where everything around where that hammerstone has struck is greater than 90 degrees, the force will just dissipate really within the core. There's no exit there's no exit point. So even when we talk about the earliest forms of stone tool technologies, bear in mind that all the makers of those flakes and cores have some knowledge at least of these napping angles in terms of how to extract these flakes. Okay, so when we are napping, we strike the top of the flake, and that then sets up the next surface for striking, which then sets up the next surface. Whoops. So flake 1 and flake 2. There are then two faces to the flake. So this is where we're going to start learning a bit of technical language. We have the dorsal, which is the outside of the flake, and then the inside of the flake is called the ventral. The dorsal will have negative features on it. The ventral will have positive napping features on it. So that's sort of how you can start to identify whether you're dealing with an outside surface with the negative impressions, or the inside surface, if you think of it like that, with the positive impressions. Your core will have negative impressions of because they relate to these positive features from the flakes that are extracted. Now I'll show you more of those as we go through. So yeah, that's what that text on the left is just saying. Just the dorsal has negative scars, the ventral has positives, and both of these show evidence of conchoidal fractures. And it's the conchoidal fractures that allow us to establish whether something is humanly struck or a natural form. So how do we identify these struck flakes? Well, we have a series of percussion features that occur as a direct result of percussion. And percussion is striking your hammerstone onto the core. These features are a point of percussion, and I'll show some pictures and examples in a moment. These are a point of percussion, a cone of percussion, a bulb of percussion. So when I look at a potential lithic artifact, the things that I sort of start to do is see if I can identify the bulb first, or where the bulb would have been. Then look at the cone, look for a cone, I'll show you where that is, and then look for the point. And if I can see those three things, generally I can be fairly confident that I'm dealing with an artifact that was humanly made, however long ago that was. If I can't find those things, then it's more likely to be a natural object. That's a general rule of thumb. There are, of course, always exceptions, which I'll try not to confuse us with as we move forward. So the positive features occur on the ventral face, and they are accompanied by other features also on the ventral, which can include what are called conchoidal ripple marks. So if I hold this flake up, I don't know if I need to turn this light on to help see. Bear with me. Okay. So as the light hits this flint flake, you might be able to see what look like ripples going across the surface. That's what those conchoidal ripple marks are. So just like when you throw a stone into a pond and you get the ripples that expand out from the point of impact, that's what you're seeing on that flint surface, conchoidal ripple marks. Sorry, my lamp is not very well weighted, so I'll try hold it with one hand and point out the conchoidal ripple marks with my baby finger there. You can see a really nice ripple mark there. And just like the stone that goes into the pond, the ripple mark will kind of tell you where that point of percussion was. So conchoidal ripple marks are really useful on fine-grained raw materials like flint to identify whether you've got something that's humanly struck. You also have what's called a bulbar scar, which is effectively, sorry if I also just remove this light, you can see that bulbar scar is what my thumb is just covering there. Okay, but I'll show you a diagram in a moment and some other examples. So to help identify whether something's humanly struck or natural, you have a kind of a suite of these percussion characteristics on the ventral face, and then you have the negative impressions of those on the dorsal face. And together, they all tell you that something has been humanly made versus naturally made. So here's a diagram showing the dorsal face, and normally in the lithics drawings, you'll find that the bulb of percussion is typically orientated towards the bottom of the object. So I orientate my flake in the same way. So you've got, let's start with the ventral surface, because I think that's an easier surface to identify things on. I've sort of shown you the rippling or the conchoidal sort of ripple marks as they move through the flint. Here's the bulb, what's called the bulb of percussion. I'll just see if I can rest my lamp there. Yeah. So here's the bulb of percussion, and then if you're looking at that bulb, you might be able to just identify where it sort of leads to a point, almost like the tip of a volcano, I think, when I sort of always look at these things. And that point is called the point of percussion. And what that point represents is the exact position on the flake of the point of impact where the napper created that flake. So, in this example, a napper struck the core with this hard hammer, that extracted the flake, and that point of impact is what creates that point of percussion. I hope that makes sense. So whenever you see a point of impact, you're seeing the exact spot, however many tens of thousands, few thousands, or hundreds of thousands of years ago, or millions of years ago, that somebody created agency in action to extract that flake. On the dorsal side, you've got then negative impression. So on this particular flake, if I hold it up that way, you can see that there is this kind of negative dip here. That negative dip is effectively the negative impression of a previous flake that's come off the top and a previous bulb of percussion. So your dorsal feature shows a negative what the ventral has from previous flakes that have come off. I hope that makes sense. Okay, so flakes are made by direct percussion. That can be with a hard hammer, so that's another piece of stone. It can also be with what are called soft hammers, and that's typically where people might use a piece of bone or a piece of antler to nap. And you start to see this as we move into the Acheulean, and people use soft hammers to try and get a bit more control and to take off thinner slices across longer surfaces. So it's about control and finesse and shaping, and I'll show some pictures of that later. People might also use an anvil. So that's where you sort of place it like chimpanzees who crack open their nuts on anvils. There's a large rock on the ground. You put another sort of the piece that you want to nap on top of that, and then you strike the top of that rock with another rock, and that between those two forces, the top and then the impact of the bottom hitting from that blow, you'll extract some flakes there. And others you can also just nap by throwing. So throwing rocks at another rock. Obviously, throwing requires a chance strike at a point to extract a flake, but some have thought that might be how stone napping sort of originates. I think it's probably more to do with nut cracking, and realizing that we can get waste debitage from chimpanzee nut cracking sites where flakes have come off hammerstones to crack open nuts. What's interesting is that the wild chimpanzee populations don't see those flakes as useful tools, but presumably at some point in our evolutionary trajectory, around 3.3 million years ago or more, some creature did recognize the potential of those flakes zipping past as a tool, and then set about trying to actually create them purposefully rather than by accident. On the core, you get the negative impressions of the flakes. So here's an example of a blade core, which is sort of related to our own species and later on in the technological realm, but it's useful to kind of see here where you get your negative impression of your bulb and point of percussion and your negative flake scar from the flake that comes off. So cores can sometimes be quite tricky to identify. Here's a core, but the way that you can identify them are successive and purposeful flake scars that are taken off around the core. If this was a natural object, you can see flake scars on this cobble, for example, but none of them are accessible from kind of, none of them are sequential, so none of them are next to each other, and none of them come from a point of the construction of a platform or anything like that. So these flake scars are natural flake scars that have occurred by this cobble bashing other cobbles in the water column as it's been moved around and deposited. So once you sort of learn, you know, the intentional features, you can then start to recognize how that might play out on a core or a hammerstone. Okay, so that's sort of just a general introduction on how to identify stone tools. What I'm going to try and do now is also just talk about different types of technology. Graham Clark in the 1960s produced the technological modes as a way of describing sort of technological change at the very broadest zoomed out level. Now, there are lots of issues with the use of the modes. The most sort of clear being that modern humans are supposed to make modes 4, 5, and 6, but they don't necessarily have to make modes 4, 5, and 6, because we know that there are sort of Aboriginal groups, particularly in Tasmania, for example, had a very basic stone tool technology that was brown core and flakes, mode 1, but a very complex organic toolkit. So, you know, just because we're modern humans doesn't mean we automatically just make blade technologies. We can make any of the technologies that precede that, I think, is the way to go. And this is the problem about us, as I was explaining earlier, about trying to assign specific species to specific types of stone tools. It's not quite as clear cut as that. So we need to be aware of, this is where context is so important, and our understanding about dating and looking at assemblages as a whole rather than individual artifacts is important. So there are lots of problems with the modes, but what they do allow us to do at a very broad level is get a sense of change through time and a sense of what that change means in terms of technological complexity and how we can then relate that to behavioral complexity and cognitive complexity. So also, Graham Clark made these modes in the 1960s. The Lomekwian was only found, I think, published in 2012. Can't remember exactly the date of that paper. So I've put 0.5 question mark. That's my own sort of pre-Oldowan, because there is a distinctness between the Lomekwian and the Oldowan in terms of the size of flake and core being manipulated. Okay, so if everyone's sort of happy and comfortable so far, we'll just start looking at these various technologies and take a sort of a bit of a journey through time now. What I'll try and do is highlight who the potential authors of these technologies are. For many of these, we don't know who exactly it is. For many, I suspect there's more than one hominin species at any given time frame. As we move through time, preservation is better. We tend to know more about the stone tools and the broader behavioral context of species. So there's often more to be said. The other thing I just want to emphasize here is I'm just looking at stone tools today in this sort of lecture, which I hope is helpful. There is, of course, a whole pantheon of other artifacts made, particularly by Neanderthals and Homo sapiens, include, you know, around jewelry use, ochre use, organic artifacts, clothing, and so on. I'm not going to address any of that today. I'm just going to focus on stone tools. You know, we really need a whole module together probably to talk about everything. So I'm just going to focus on stone tools today, but don't forget there's a whole series of other objects out there that tell us about behavioral complexity. So the Lomekwian is the oldest known, or sort of the oldest currently known stone tool technology, dated to about 3.3 million years ago, and published by Sonia Harmand and team. And I think this kind of timeline at the bottom is probably a really useful sort of graphic to kind of start to see a bit of the difference between what is the Lomekwian versus the Oldowan and the Acheulean. And effectively, the Lomekwian are large flakes that have been taken off large cores. No real shaping to them, a little bit of retouch around the edge, sometimes that can be damage. But the point is that the flakes are larger than what you typically see within the Oldowan. Within the Oldowan, you have flakes that have been produced, but you also have cores, and the cores in the Oldowan are not just raw material sources. Some of them themselves become tools, what we call chopper tools, and like this one here, and that's what can be used to crack open long bones to get to the marrow and that sort of thing. And then the Acheulean, which the oldest examples come from about 1.7 million years ago, the Acheulean represents the point in the archaeological record where we start to see the deliberate imposition of shape and form being imposed on material culture. And I'll talk about why that's important when we get there. So the Lomekwian, sorry, let me just go back, is about these large flakes and cores that come from the site of Lomekwi. And there's a really fantastic website, which I'm going to try and access for us now, where you can actually have a look at some of the Lomekwian artifacts and the excavation. It's africanfossils.org. It's a really fantastic website that allows you to have a look at 3D models of fossil remains, but also 3D models of animals and tools. So I'm just going to go to the Lomekwian industry. And here we can see some of the artifacts from the Lomekwian. I'm just going to focus on this one here, which is probably the most obvious flake from the Lomekwian. And forgive me while I try and drive this in a way that makes sense and hopefully people don't feel seasick. So the face that we're looking at here is what I think is a ventral. And even the thing about lithics analysis, okay, is you can do it for 10 years, but you can still come across pieces that you don't know what they are. You can be uncertain whether they are natural or whether they are anthropogenically made. So it is tough, it's not easy, and but it's hugely rewarding. So I think this is the ventral, largely because it's a fairly flat surface going down. The bulbar percussion, I think, is probably around here somewhere with a point percussion here, but not having seen the object in person, just virtually, I could well be wrong. And I think on this side we have then the dorsal, which is where you can see these negative features from previous flake removals. But if you're interested in seeing more about the Lomekwian, do have a look at the africanfossils.org website. There's some really fantastic resource here. The other amazing or great point of access is that you can watch a time-lapse video of the excavation for Lomekwi, and it shows the artifacts coming up. We might have a quick look actually if we've got time. You can see sort of the excavation from beginning through to end, and it sort of gives you a nice idea of how these types of tools are excavated within an East African context, which will be very similar, I think, to how you do it in India. So probably this is already quite familiar to many of you. But what this video does usefully do is it shows these objects coming through not just as surface finds, but as in situ, in context artifacts. And also helps you start to identify where some of the refits are. And I think it also is useful to see what is possible with sort of technology these days in terms of digitally recording sites to allow people to access that excavation process once it's complete. Because as we all know, excavation is a destructive process. And once you excavate those sediments and take those tools out of context, a lot of that information is lost. But with these sorts of digital recording techniques, you can revisit it time and time again. And I think that's going to be a hugely important role in the future. Okay, so, I mean, there's not really much we know about the Lomekwian. It's from one site, there's one paper published on it. I'm sure there's more to come in the future and I eagerly await it. But for now, the paper's there and the link to the African Fossils website is there to kind of actually have a play and have a look at some of these things yourself. Okay. Sorry, let me just try and move the screen slightly. Okay, so in terms of when the Lomekwian occurs 3.3 million years ago, the reason why this discovery was so significant was because prior to the Lomekwian, there was a big debate about whether stone tool use was only limited to the beginning of our genus, Homo, at around 2.5 odd million years ago. The Lomekwian pushes stone tool use manufacture beyond the origins of our genus. And actually, it could be Kenyanthropus platyops, Australopithecus deramida, Baroghazali, or Afarensis, or some other unknown hominin fossil that has yet to be discovered. I know that some people consider Kenyanthropus plateops to be a precursor to the genus Homo, so they could well be the authors of the Lomekwian stone tools. Could equally be an Australopith. We don't know who made it. They're not found in any fossil association at all. But it is really interesting that it pushes back the Lomekwian, stone tool use beyond the beginning of our genus, and actually probably now starts to lend some credence to the Dakika cut marks that were found prior to the Lomekwian being discovered, but were always treated with a bit of caution. Some people think they might be trample marks rather than stone tool cut marks, because they were so old. You know, the Dakika cut marks are even older than the Lomekwian tools, but now actually, you know, maybe they are stone tool cut marks. I'm not a fossil expert, so I'm not sure I can comment, but it's intriguing that now stone tool use is not just the realm of the genus Homo, which used to be one of the early defining characteristics when talking about Homo habilis. Sorry, I've just got a Homo habilis, which we can see an example of a fossil skull cast here. Okay. So the next sort of stone tool technology to look at is the Oldowan, which is called Mode 1, and is defined by what we refer to as a core and flake technology. And the oldest instance of the Oldowan is about 2.6 million years ago, often associated with Homo habilis or rudolfensis, so our genus, but just by the other sort of species that are around at the time, could be Australopithecus afarensis or maybe even a Paranthropine, but most people tend to associate the Oldowan with the beginning of our genus, which is habilis or rudolfensis. And the thing about the Oldowan is it's a, you know, I tend to think of it as it's a mode of stone tool technology that is designed to create a sharp edge, and that sharp edge can be through a flake, or it can be through creating the edge to a core like this one here to create a chopping tool. So, you know, these sort of blue diagrams are quite useful conceptually to kind of see how you might go about napping your nodule. So you look to extract a few flakes through direct hard hammer percussion, create sort of no real shaping or form goes into the Oldowan. It's about creating a sharp edge that you can then use to crack open long bones, or if it's a flake, to kind of cut and butcher the animal hide or the flesh within that. The Oldowan is defined from artifacts from Oldupai Gorge. So there are hammerstones that have been found. People have also then classified various types of choppers, but the choppers we think are probably all about bone breakage. Discoids is just a type of core which requires sort of some bifacial flaking to extract flakes. Polyhedrons are multifaceted cores. And the other kind of key feature is that these heavy duty scrapers. So a scraper would be a flake that is napped but then retouched along an edge, and the purpose of retouching on the edge actually dulls the edge slightly, but it makes it much more durable. So when you have a very fresh flake, say like this one for example, the edge is very sharp, but once you start to use it, it will dull quite quickly. So if you want to create a more durable edge, you would just put a bit of retouch on it, if I can try and get the light right. So as you can see here, a bit of retouch along the edge dulls it slightly, but does make it more durable, so you don't need to constantly resharpen. So these are processing tools. I think, you know, I think of them as processing tools for carcasses and maybe wood. The other really interesting thing around Oldowan toolmaking is that Dietrich Stout and colleagues some time ago now, 2008, got modern day Homo sapien experimental nappers to replicate a number of different technology types, including the Oldowan and the Acheulean. And whilst they were napping, they conduct brain scans to try and see what parts of the brain were firing in the making of that technology. So, of course, caveats accepted that it's a modern human brain rather than, say, a Homo habilis brain or a erectus brain or whatever. But I think actually it shows some useful insights. And the key thing about the Oldowan is that the parts of the brain that were firing were the ones that were related to motor control, hand-eye coordination. So they were really focusing on manipulating the object in a way that didn't lead to a failed core, or a core that you couldn't access anymore because you hadn't maintained your flaking angles through the reduction sequence. And what I mean by that is, on this core, if I just napped all along this edge here to take away this tip, I would very quickly possibly, end up with a core that I couldn't then reduce anymore because I had destroyed my 90-degree angle or less, in a kind of a basic way of thinking of that. But don't be lulled into thinking that the Oldowan is a simple stone tool technology, or that the nappers of the Oldowan were not complex. They absolutely were. And the site of Lokalalei in Kenya, dated to about 2.3 million years ago. Sorry, let me move the screen this side. You have 2,500 stone artifacts from 10 different raw materials. So raw material difference is important because it shows that these hominins are able to apply the napping knowledge that they have to different raw material sources. And these materials are procured from stream gravels, and at Lokalalei, they have 63 refit sets. So they're able to understand the napping process and that the nappers went through to kind of get the end result. And what they show is that these nappers are selecting fine-grained cores more. So they have a knowledge about raw materials, and they know that fine-grained raw materials, you don't get flint in Africa, but flint and cherts are fine-grained siliceous materials, and fine-grained materials are easier to nap. So maybe these sort of fine-grained volcanics, like this flake here, which is from the site called Isimila in Tanzania, would be sort of a useful, interesting example of that. So fine-grained raw materials nap easier. They're extracting large flakes from these cores, up to 30 sequential removals. So to extract those kind of 30 flakes, you've got to be able to maintain your napping angle through your 30 sequential strikes. So to do that, you've got to be able to manipulate your core in multiple directions, mentally thinking about, if I take this flake off here, what's that going to do to the overall shape? Which means I have to then take off one there, and one there, and one there, and one there, and one there to maintain my napping angle. So they're turning these objects in multiple directions in 3D, thinking in 3D through that napping sequence to produce a really efficient flaking of those rocks. So that kind of really opens, once we start to get into the technicalities of how to nap, that really shows that these Oldowan nappers, despite it being what's thought of as a simple technology, are actually very complex and accomplished nappers to be able to think in that kind of 3D way. So, if it is Homo habilis, this is to scale. This is a creature whose brain is much smaller than ours. And so cognitive abilities are not sort of near what we can do. We can think in 3D relatively easily, and we can turn tools. But, we have big brains that we've been using for many hundreds of thousands of years to kind of develop those sorts of plastic abilities. This is the beginning of our genius. But to nap in that way, it shows planning and foresight and quite a sophisticated understanding of raw materials and what we would term fracture mechanics. They obviously wouldn't have thought of it in that way, but quite early on, even in our most simple technologies. Flake and core, or mode 1 technologies, are found in Africa. Southern Africa. Versions of flake and core are found in Northwest Europe, around Spain, also at Dmanisi about 1.8 million years ago, which is the red circle, and in Southeast Asia. Now, as I said at the beginning of this, I wish my knowledge of the Indian Paleolithic was greater than it is, but I don't think, please do correct me if I'm wrong, that there's been any Oldowan or mode 1 type technologies found in India. I think what was the Soan maybe, which was thought to have been mode 1, is now recognized as a mode 3 technology, Lavawa. But certainly it seems that hominins were moving out of Africa at least 2 million years ago and taking this mode 1 technology with them. And so you didn't have to be large-brained, and you didn't have to be sort of an erectine grade hominin using hand axes and all the cognitive plasticity that gives you, which I'll talk about in a moment, to move out of Africa and be successful, or at least survive in these different environments. I know the Dmanisi hominins, for example, were having quite a tough time, it seems. Okay, so that sort of leads me to segue then into the Acheulean. And the thing to bear in mind is, okay, as we move through these different modes of technology, the name is given around one particular type of artifact, but actually, you know, with the Acheulean, they're still making flakes and cores and flake tools alongside the hand axe. The hand axe or the biface is just an additional tool to the pre-existing toolkit. So it's, you know, that's why I sort of say we need to be careful about how we use and structure our understanding of these lithic technologies through time, because it's not so simple in terms of that a linear way of hand axes, and that's all they do. No, they still make cores, flakes, and flake tools. But there is one big difference with the hand axe. So, you know, sort of in this diagram, you've got your nodule that you're napping to extract, and with the hand axe, you're starting to impose deliberate form and shape onto that object. So here's an example of a hand axe from Kilombe. This is a cast of a hand axe from Kilombe in Kenya. It's probably somewhere, I think it's around $1 million. I might be wrong. But it's certainly sort of the oldest example I have in what's available to me here at home. But you're starting to impose deliberate form and shape on the hand axe. Now, hand axes have been around for about the earliest ones are made at 1.7 million, and as I said, they kind of extend around to about 200,000 and younger. Hand axes also, you're imposing deliberate form and shape in terms of what are rough outs. So that's number 4 in this diagram. You might use a soft hammer like bone or antler in number 5 to kind of give fine tuning and fine shaping, and that's possibly what you might see with this example here, which around this tip, which has got very fine small flake removals. A lot of attention has been paid to the construction of this tip of this hand axe. This is probably about 200,000 years ago from Britain. But I think the thing that really makes hand axes special or interesting to me is that in order to make this, it's commonly understood that you have to have a mental impression in your mind about what you want to make. So before you start napping the hand axe, you have to know that you are making a hand axe and roughly what shape it is before you start the napping process. Now, you could randomly nap a core and produce a hand axe in the same way. The way that I think of it is that chimpanzees bashing a typewriter will randomly eventually produce the works of Shakespeare, if you've heard of that analogy, but it's not sort of as directed. Although safe to say that there have been some really interesting studies by, I think, Steve McFerrin, who has suggested that you could make a hand axe by randomly napping. But I still think that for most hand axes, the nappers have a mental template in their mind, however flexible or rigid that may be, about what they want to make before they start that napping process. And that's the important cognitive shift for me. But if you're holding that mental image in here, you're using your imagination. To use your imagination, you have to sort of access your ability for abstract thought. And that's the big difference between Acheulean assemblages versus Oldowan or Lomekwian. Those assemblages can be made, their shapes are determined by the natural fracturing process that is controlled by those hominins. But with the Acheulean and the imposition of form and shape on the object, they're doing so because they can think abstractly, because to be able to make one of these successfully, you've got to have an idea of what you're making before you start that napping process. The other thing about the Acheulean or these mode 2 technologies is that they are seen to be functional objects for butchery or manipulation of wood, but there's also a big question about whether they are the first examples of material culture that carry some form of social or cultural meaning to them. And I think that's really exciting and interesting, because in order for that to be true, you've got to have a commonality of understanding. So you've got to have a common cultural framework within the group who can all read and understand what that object's supposed to mean at a social and cultural level. And for that to happen, you've presumably got to have some form of language. It doesn't need to be grammatical language at this point, but there's got to be a commonality of communication there. Now, we use material culture in a social way all the time. in our modern world, we tend to perhaps use brands in that way. So, you know, whether you've got an iPhone or an Android might say something about who you are and what sort of buying power you have access to. The kind of designer clothes you may or may not wear also sends that kind of social message. But we engage with material culture at this level all the time. Even if it's not about brands, just the style of dress tells somebody else about who you are. You know, I'm wearing a tie today and a waistcoat, and I do that when I kind of want people to know that I'm spending my time with them in a serious way, and I want to kind of create a certain impression for you, you know, that I sort of take this seriously. If I came in with a sort of a t-shirt with holes in and things like that, it might not create that same impression. So we use material culture to signal something about ourselves to our audience all the time. But what's interesting is where in the archaeological record does that sort of ability occur? And that, you know, many of us think that that's with hand axes, and I'll go on to explain why that might be in a moment. So the other thing to understand about hand axes is that these come in a variety of shapes and forms. So here's a pointed hand axe, for example. This is actually a particular type that we have in Britain called a ficron, where the tip is very, very finely worked and shaped, and then it kind of leads to a bulbous base, which is less finely worked and shaped. But you also have hand axe shapes like this one here, which we call an ovate, because it's largely oval shaped. And there are other hand axe types like the cordiform that you can see on the screen. And for Neanderthals in Britain, they make a particular hand axe shape called a bouc coupé, which is sort of this D-shaped hand axe, which seems to be a marker of Neanderthal. Only Neanderthals in Britain seem to make that type of hand axe. So, you know, what are hand axes and why do hominins make them? Well, they are butchery tools. So we know that there's a clear functional purpose to the hand axe, often given the label the penknife of the Paleolithic. However, because of the attention to detail and form that is given to these things, lots of people consider them to be over designed for just a butchery role. So that's premise number one. Some of these hand axes, you know, all the examples that I'm showing you today kind of fit the appellation hand axe because they fit nicely in the palm of my hand. I'm not straining to hold them. They're not too heavy. Their size is not too awkward. And, you know, they are objects that you can manipulate to butcher your carcass. Some that I'll show you have been thought to be too large to be functional. The giant hand axes. You also find hand axes, depending where you are, in large concentrations. So why make so many of an object that's just about, if it was just functional? And some have thought that the shaping is over designed to just be butchery. I think Kuhn and Meithen suggest a mechanism by which hand axes could be more than just functional in their sexy hand axe theory. And I mention this because I don't necessarily agree with this idea, but it is an idea that is quite accessible in terms of seeing how an object, like a hand axe, could have something more than just a functional purpose to it. So Kuhn and Meithen's idea is that the napper of the hand axe was imposing symmetrical form, and the more symmetrical and the more finely shaped your hand axe were, the more skilled you were, and therefore the more attractive you would be as a mate. So for them, it was male nappers demonstrating their skill through the production of hand axes to attract females. Now, of course, we don't know which sex was producing hand axes. Personally, I think males and females were probably napping. I don't think it's sex specific at any point until maybe much later in later prehistory. But using the heuristic of the sexy hand axe idea, you can start to see how an object, a stone object, takes on greater significance beyond just function. And I think that insight and the application of insight is quite a useful one to kind of see how that would work. In addition, you get objects like the one that I'm holding here, which is a giant hand axe from the site of Isimila in Tanzania, where the tip's been broken off here. You know, these very large hand axes are also very heavy. So it's difficult to see how they might be functional. Some people have thought they might be for butchering megafauna. But I mean, I'm struggling to hold that one, if I'm honest, and I don't think I'm sort of I think I'm pretty average in terms of build and strength. So, if that's difficult, I couldn't really see how you would manipulate it if you're trying to butcher an elephant or a rhino or something like that. So, it's not just about size, it's about weight too. And certainly other examples from Miss Amila are highly formed and hugely symmetrical. I spent some of my career, a large part of my hand axe analysis, suggesting that symmetry is not a predominant form in hand axes, but it is a significant minority. But actually, the Samila, they are some of the most beautiful symmetrical hand axes I've ever seen. So, they're highly designed, and we don't know what that is, but their size and their seemingly non-functional ability suggests that they might be a social reason here. I think there is one functional aspect that someone once told me, I think it was Laura Bazell actually, around giant hand axes, and that was people using pointed large hand axes to dig down very rapidly into dried up pond beds to catch catfish that were sort of submerged underneath. And I think that could be a really reasonable explanation, and would use the weight of the object to the advantage. Others suggest that maybe these things are embedded in the ground with an edge up, and then you would use that exposed edge to kind of process a carcass or something. That's also a possibility. So yeah, but I think that the thing with hand axes is that they're functional, but they're also likely to be social and cultural too. The other thing about hand axes is that a skilled napper can produce a hand axe in about 15 minutes. So that's sort of a hand axe like this could be made in about 15 minutes. And we know that from experimental archaeology, but also there's a site in Boxgrove dated to in Britain called Boxgrove, dated about 500,000 years ago. And the snapshot here on the right, which I think is genuinely phenomenal, might just look like some flakes on the ground. But what you're looking at is a moment 500,000 years ago that lasted between 15 and 20 minutes. And what you're seeing here is the debitage of a hand axe. And all of these flakes refit together, and you can actually get an impression of what the hand axe shape was that was carried away. But the napper sat there, napped their hand axe, stood up, dusted themselves off, and walked away. So where you see these flakes on end, that's actually the imprint left by that napper's leg 500,000 years ago. So, Paleolithic archaeology is difficult. We often work in secondary contexts and things that don't make, that aren't in primary context. But those rare moments where we get the primary context, boy, I think that's a real mind-blowing moment. What you're seeing here is a 15-minute episode 500,000 years ago. Really astonishing. The other thing about the Acheuleans, I've sort of intimated already, is that they use soft hammers. So that's bits of bone or antler. I know that modern day experimental nappers, certainly in the UK at least, really prize their soft hammers. They hang on to them at all costs because they get to learn the weight and the balance of them when they're napping. So they know exactly where to strike something to achieve a certain effect. And at Boxgrove again, we have evidence of soft hammers being preserved across the landscape. These are bone, I think they're from elephant, which have been used as soft hammers to nap some of the Boxgrove hand axes. So, there's tools to make tools, and those tools to make the tools are being preserved and conserved by the groups as they move across the landscapes. So there's another sea change there in cognition. Dietrich Stoutetal also sort of did the brain scanning on Acheulean napping. And what's interesting when you compare it to the Oldowan napping with all the caveats in place, is that much more of the brain is activated when napping hand axes. And I think what's really intriguing is that you start to get parts of the brain associated with language also firing when you nap a hand axe. So there may be some links there, some neurological links to the origins of language, not grammatical language per se, but language as a symbolic system of communication, which could be through signs and utterances rather than complex grammatical syntax like we would use. And certainly in India, there's now a really well-established Lower Paleolithic record, Acheulean record, with some really amazing looking cleavers, as well as sort of hand axes that have work's been done over the last sort of 10, 15 years to establish this. And although I haven't seen any of it myself, I'm told that a lot of it sort of bears close similarity to some of the Eastern African cleavers in terms of the technology of production, side struck flakes and so on. But India has a real story to tell around the Lower Paleolithic still, and that's the Acheulean and potentially even the Oldowan. So there's some really amazing archaeology in India, even more amazing than we thought previously. Just wanted to also highlight that with the Acheulean, we start to get preservation. So in the younger end, we start to see organic artifacts being preserved. So at Clacton, for example, in the UK, here's a wooden spear with a fire-hardened tip, dated to about 400,000. The same at Schöningen in Germany, where you have the preserved spears that are both long distance, so throwing spears, as well as shorter thrusting spears found in association with horse carcasses. And in Italy, we also see, and at other sites across Europe and around the world, not only are hand axes made in stone, but they're also made in different raw materials like bone. And here's an example of a bone hand axe being knapped at about 460,000. So why that's significant is that there's a cognitive development here where the knappers of hand axes are able to cross raw material mediums to produce the same sort of object that they want to. And that's quite a broad cognitive Rubicon. Okay, moving into then around 300,000 years with what's called prepare core technology in European typologies. This is now the Lavawa. In African typologies, it's the Middle Stone Age. And normally in Northwest Europe, Lavawa is associated with Neanderthals, and the Middle Stone Age is associated with the origin of our species, Homo sapiens, in Africa at about 300,000. It might be that some Heidelbergensis were also producing these things towards independently innovating some Lavawa type technologies towards the end of their time span. I don't have a problem with that if they were. I think it fits the broad complexity of human evolution. But Lavawa, or prepare core technology, represents a real sea change in how raw material is approached. So rather than napping around a core, so sort of striking here to extract a big chunk of flake, what Lavawa and prepare core technology is doing is creating a top napping surface like this one here, which can be exploited time and again and reworked to extract flakes of a predetermined shape and a predetermined size. And the reason why that's important is there's also, along with that sort of technological standardization of artifact manufacture, it also comes with a complete reworking of raw material use. So suddenly one core becomes many objects, whereas whereas a hand axe is a hand axe. It might have many functions to it, but actually a core could be functionally many different things, and I'll explain that in a moment. So where the hand axe is thought to be the Swiss Army knife, I often think of the Lavawa or the Mode 3 prepare core technology as the Leatherman of the Paleolithic in terms of its versatility. And the interesting thing here is that you can extract, you can prepare your core surface to extract one large flake off the top. You can then re-prepare that surface and you can extract two smaller points for hafting into spears. You can re-prepare that surface, extract another large flake again. So there's what's called a volumetric approach to the core, where you're looking to maintain this flaking surface as you move down through the raw material, rather than sort of reducing the surface area. And then with Lavawa, rather than kind of napping it sort of top down, you would try to strike it from the side to extract a large flake that would then come off. Okay, that's actually a failed Lavawa core. There's a sort of a hinge fracture in there, but the points sort of you can see. So here's the volumetric approach, where you're kind of creating these two planes of intersection, a top surface and a bottom surface, and effectively you're looking to keep this top surface, if I use this as an example, you're keeping that top surface as large as possible as you move through the core reduction. So the reduction of the core is down like this rather than around. if that makes sense. And by doing that, you can then create a very versatile core where you can create large flake extractions or multiple small ones, re-prepare that surface. And the point with all of that is that you know exactly the size of flake that you're going to extract and the shape of flake. So there's a technological standardization here that may also have cultural implications, but it's largely technological with Levallois. Now, in the sort of Northwest European context, the probably the most famous flake type to come through is what's number 3 in this diagram, called the Levallois point. And when you start to produce Levallois points, the implication there is that these are stone tips, so you're moving into composite tool use. And I'll talk about composites more in a moment. Here's just some other examples. We call these laminar or blade Levallois, different to the blades that I'll talk about in a moment with modern humans, but you can produce them in a Levallois technology as well. Here's an example of a point. And here's an example of what's called a radial flake, sometimes called a tortoise shell flake, where you kind of have these flake scars from all around. So, you know, with these Levallois cores, you can produce your points, you can produce your radial flakes, which might become a hand axe in their own right, and you can produce those laminar flakes, which you could then use to produce scrapers, all from one core. And you can do a large radial flake with one removal, 2 points with the next removal, 3 laminar flakes with the next removal, back to a large flake, which will be the same size as the one you made originally. And you can do that sequence in any order as many times as you like. So it's a really versatile kit. Certainly within India, you also have sort of an emerging understanding, I think is fair to say, of prepare core technologies, mode 3 technologies. Only in that a few sites have them, but that's just research bias. They're there absolutely in much greater numbers than I know about. And you know, they are really fantastic examples too. Here's one that's even got a bit of working around a tang for hafting. So, you know, it's the same sort of things that we're seeing in Africa and in Northwest Europe as a mode of technology. So what's the advantage of Levallois? Well, ultimately, it's a mobile technology. So we're starting to see a movement in subsistence strategies, I think. With Levallois and Mode 3, you're starting to see small, highly mobile groups of people moving across landscapes. And that's because with these cores, suddenly you're not so tethered to having to find suitable raw materials all the time, because you have a raw material source that you can adapt and change to any circumstance you might require. So with one core, you can make a hand axe, you can make a scraper, you can make a point for your spear, and you can do that until you run out. So you could carry 2 or 3 of these cores, where you might have to carry in a more handheld processing type technology like the Acheulean, you'd have to carry 5 or 6 of these things. 2 or 3 of these would achieve the same end. So you're suddenly much more mobile across landscapes. Some big flakes themselves can become cores for further Levallois detachments if you need them later on down the line. So there's an element of much greater time depth and planning as you move through them. And you know, the different napping strategies of Levallois give you adaptability to different scenarios. So one core can be many things at the same time. The other really interesting thing about prepare core technologies is the amount of cutting edge you get from a core changes dramatically. So with the Oldowan, these are all scaled to the same nodule size. With the Oldowan, you could get about 2 inches of cutting edge. With the Acheulean, you might get about 8. Well, with Levallois, you're dealing suddenly with 40 inches of cutting edge. So, you know, it's really much more adaptable and versatile. The other key thing around Mode 3 is with the manufacture of these Levallois points is that, yeah, these are clear indicators of composite tool technology. And with composite tools, you know, you've got to bring together multiple raw materials. So you've got to produce your haft for your spear. You've got to produce some sort of mastic or glue, which itself is a combination of multiple raw materials. So animal fat, ochre, ash, resins to create a sticky glue. You've got to heat that some way to kind of melt it all together and then apply it to your flake and your haft before it cools too much to make it unusable. So you've got to get your timing of combination right. And generally you also have to have some sort of knowledge around cordage, whether that be through animal cartilage or plant fiber. So actually with the advent of composite tools, suddenly there's a cognitive leap around you know, and complexity in terms of the chain repertoire, the manufacture process from start to finish, and bringing different raw materials together. And these are all unique. So, you know, a composite tool is genuinely an artifact of the imagination. There are some arguments people make around hand axes that, yeah, there could be objects of the imagination, but equally, if your nodule is long and thin, your hand axe is going to be long and thin. Therefore, the shape of it is predetermined by raw material and not necessarily the mind of the napper. And that is true in some instances. But with composite tool technology, that is entirely an artifact of the imagination and abstract thought, because there is nothing in nature that creates composite tools that you can mimic. So that's genuinely an object of the imagination. I think that's really, really significant from a cognitive perspective. Larry Barham also has linked that to the beginnings of complex language and grammatical structures as well, from a cognitive perspective, in terms of coordinating all these things together. Also with mode 3 technologies, here's an example from Neanderthals. As you start to get variants of the technology, so technologically they're all the same, but they are shaped in slightly different ways and forms in different locations. So the emergence of specific cultural groups, and you see that in Africa and I'm sure in Southeast Asia as well. Okay, now into sort of blades and modern humans. So the thing about blades is that this is a prepare core technology as well, but it's a different form of prepare core technology. And the object of blade production is to produce these flakes, which are long and thin. Both of these examples I'm holding up are from later prehistory, not Paleolithic ones, but they sort of serve the same purpose, I think, in terms of the illustration. And again, this is a sort of another sort of sea change in approach to raw material use. You know, just from this diagram, number 8, you can start to see how many more flakes you can extract from a blade core, and they're all going to be standardized in terms of their length and broadly their shape. And then you can either use, you know, that flake as your spear tip. You can deliberately break it and slightly sort of nap a burin spool off, which is what we call this the small removal. And if you do that, you create a really hard edge, which we typically think is used for engraving, maybe of antler, bone, ivory, or wood. So, you know, it's about versatility and movement across landscapes. Blade core technologies are associated with Homo sapiens, both within Africa and outside of Africa, and it's often used as a marker. So if you have blade core technology, that's seen as a proxy for modern human presence. Although I think there's a growing literature from a few sites where it seems that Neanderthals and other human species, maybe like the Denisovans, were also producing blades independently. Blade cores can also be produced in later prehistory through the use of punches and pushers. So you're really kind of maximizing your raw material use. And if you look at that raw material use with blade sort of cores and napping of blades, the number of cutting your sort of cutting edge is between 1 and 40 feet rather than the inches that you see before. So it really is about versatility and maximizing raw material use. And of course, you know, these are then, you know, linked into other developments around what Homo sapiens we're doing in terms of producing more advanced projectile weaponry. So you've got the spear throws here, which we typically see within the European record after the last glacial maximum, so sub 18,000 years ago. And that's where the spear throws are extending the length of your arm so that you've got more force and distance when you throw things. You also see these blades sort of cores in Africa, across Africa, and different types of cultural expressions of those. I don't have time here to go into the finesse of the small of the kind of the idiosyncrasy of these local types, but you know they're all there in terms of that prepared core technology. And of course, in India, you also have examples of these blade cores. So, you know, they are ubiquitous with the dispersal of Homo sapiens. So coming to the end now, you might all be relieved to know, I'm just going to sort of focus a little bit on the European later prehistory. This is not really my period at all, I hasten to add, but there's just a couple of kind of key points perhaps to illustrate. Once we get past that kind of mode 4, blade technology, we enter what's called mode 5, microlithic technology, and in Europe that's associated with the Mesolithic. And the microliths are still producing blades, but they are blades which are then deliberately shaped and broken into these trapezoidal shapes. And these trapezoidal shapes can then be used can be inserted as barbs into bone or wood, or ivory even, points. So you're creating effectively stone barbs which will lacerate and cut up inside your prey when you attack them. Into the Neolithic, we have certainly, at least in Northwest Europe, the kind of the polished stone axes from the Neolithic, and the polishing of the axe, it's thought could be very much linked to social and ritual things in terms of trade, and we see something like that in Papua New Guinea as well. Although I'm not drawing any form of clear analogy between what happens in Papua New Guinea in more recent times versus the Neolithic of Britain, but the polishing of the stone axe, it's interesting to see how they do it there, to give some insight into how it may have worked in Britain some time ago. But the other thing about the Neolithic is that you've got these polished stone axes, probably polished to create a more durable edge, and then these things may have been used in forest clearance as well as trade. Here's an example of a broken tip of a Neolithic hand axe, axe here, and it's actually broken pre-polishing. There's a little bit of polishing on this underside, but you can actually see how the original napping and flaking would have been to create that shape, which the polishing with sand or grain on a hard surface would have erased those kind of previous flake scars. So stone tool use persists after the Paleolithic, even though we're kind of moving into now the established, well into the realms of agriculture and sort of growing city states and that sort of thing. Within Northern Europe, stone tools are still continuing to be used into the Neolithic, and they've become quite elaborate in their form, and I think probably almost certainly are expressions of skill. I mean, the people are making fish hooks out of flint, really elaborate arrowheads with barbs. These are really skillful and nappers at play here. And what's interesting also, is they are also starting to mimic the origins of early metal use. So objects made in metal are being mimicked in stone tools towards the end of the Neolithic, and we can see that in, I think these are Bronze Age. Sorry, let me just try and move this out of the way. These are still in the Danish Neolithic. So here's a stone mace head or axe head, but it's actually made to mimic the production of a metal object in the same way, right down to the expression of the kind of seams from casting. And here's a late Danish Neolithic copy of a metal dagger in stone. So, the point I'm making here is that stone, just because we start to enter the metal ages, and I think this is true globally, just because people are starting to use metal, stone continues to play a really important role within these societies. It's a changed role. Maybe it's more around ritual and symbolism rather than function in ways that the metal's kind of taking over. But you don't just wake up in the Bronze Age or the Neolithic and you stop making stone tools. These things persist through time. And here's an example of the Ystrad dagger, which is a really beautiful piece from sort of 3,000 years ago, really made to kind of mimic the copper and bronze daggers and knives of the same period. So, stone tool use continues to be important long after the Stone Age, after we stop calling things as being part of the Stone Age, is my point. So to come back to the slide finally that I showed earlier in terms of why stone tools are important, well, hopefully I've been able to show you that stone tools and other artifacts offer evidence about how these early humans made things and how they lived and how they interacted. Hopefully I've been able to kind of give you an introduction into how you can access cognitive abilities and more complex behaviors through the production of stone tools, composite tools, hand axes. And really what's important is that these stone tools provide evidence about technology, dexterity, mental skills, and innovation. I've given you a very broad overview of technological change through time at a very global, the most zoomed out level you can possibly be. On the ground, there's much more complexity around regional variation, regional differences, and lots of these things that I haven't pulled out. But I don't have the space today to do that. So, just keep in mind that I'm speaking at the most zoomed out level possible. As always with archaeology, things are much more complex and nuanced when you get to kind of the detail.